Hello guys, in this video we will see the new problem, that is you are given a linked list. You just want to check whether the loop is there or not in a linked list. We just want to return whether it is a true or false. We just want to return whether it is a true or false. You are given a loop. What is the loop indicates? If it's what actually loop indicates? If you actually start moving from point A and you went. Again, you came back to point A. Again, you came back to point A. That is called loop. You came back to the previous position where you are. That is called loop. All. Not only this is starting point, not only a starting point. You started from here, point A, and you went to point B, and you came back to point B. This is also a loop. Now here the starting point will be B. When you are going, again you came back to the point at which you already went. That is called loop. So the same thing applies in a linked list. One next is two, two next is two. When you want to traverse the linked list, the traversing a linked list is in one direction, right? Two will go to four, four will go to five. Next again five is going to two. Again five is going to two. Two has traversed, five is going to two. That means there is a loop here. But there is a loop. Here this the starting node is two. Again we came to two. Again we came to two. But this is true. This is a loop, and this is not a loop. There is no loop here. There is no loop. And you can also say that in linked list there is no null. There is no last node in a loop. There is no last node. You can see there is no end point. There is no last node. Here there is a last node null, but in this linked list there is no null. So there is no there is a loop. If there is no null, there is a loop. Okay. How can we do this problem? How can we do this problem? The first intuition from this approach is um, see when when I traverse two nodes in the iteration, when I traverse the two nodes multiple times, then there is a loop. See what I'm going to say is I'm considering a hash set. The hash set name is visited node. I'm considering this name as visited node. Let's consider this as visited set. This hash set is visited node. The name is visited node. Now I'll start inserting the addresses in the hash set. Remember, I'm not inserting the data, I'm inserting the addresses. See, initially my pointer is here. I'm keeping a pointer. Initially my pointer is here and I'm inserting the address of one. Again, my pointer will move to 2. Now, insert. Is it visited? Still it is not visited. So if it is not visited, then insert. Next, it will come to 3 and check. whether the address of the three present in the hash set or not. It is logged in. That means is we can insert into a hash set and the node 3 is not visited. Next, 4. If you go to 4, it will insert 4. Similarly, the address of 5 also will be inserted. The address 5 also be inserted. And then after 5, where it will go? It will go to 2. Right? It will go to 2. Now my pointer is again came to 2, but it is already visited. It is already visited. It is already visited. That means that means there is a loop in a linked list. That means there is a loop in a linked list. There is a loop in a linked list. So my question is, can we optimize this solution? Can we seriously optimize this solution? Okay, let's see the time complexity for this. So what we are doing is we are simultaneously doing. Checking. We are checking for searching. We are checking n login. We are searching. For searching, we are searching in a hash map, right? Whether this node is hash set, sorry, whether this node is there in a hash set or not. We are checking, right? So for checking, it will take login time and it is executing for n times. So n login. And after checking, and we are also doing the insertion. Each insertion take place order of n one time in a hash set, and also it is taking n times. So the time complexity for this is order of n log n plus n is the time complexity, and the space complexity will be order of n is the space complexity. So can we decrease this space complexity to big O of n, and it can be decreased this to time complexity to order of n. Can we do this? You can do this, but this if you are getting this idea of this approach, then you are going in a good way. But the approach now I am telling is a completely mathematical approach, completely very very important approach, and also completely it is a mathematical based. I'm again repeating, complete it is based of mathematical. So let's discuss optimized approach. Before discussing this optimized approach, I want to tell the mathematical concepts. I want to tell some mathematical situations, some physics situation, mathematical situation, some situations I want. You can also think of physics situation, kinematic. Is this a kinematic situation where we have seen in the last section while finding the mid, we have seen that kinematic situation. If a two persons are moving with different speeds, one is double than other, the person who is going very slow, where is he? Same like that situation, we will answer in a different way. Let's see that situation. I'm considering a one situation, the same situation. There is a point A, there is a point A, and there is a circle. You can also think there is a circle. You can also think that like there is a circular road. A circular road. You cannot. There is no. It is a circular road. You can think, like there is a circular road. It is going in a circle. There is no way here. It is closed. Everyone should go in a circular way only. Everyone should go in a circular way only. Everyone should go in a circular way only. No one cannot go from here. Everyone should go in a circular way. This is the situation I'm thinking. I'm taking. Now, so I'm just removing this. So everyone should go in this line only. No one should go in the middle of space of a circle. There's a point here, and there's a circle. Now, no, this is the starting point. I'm considering the same situation. There are two persons. I'm still considering the same situation. There are two persons. Person one, and they both are in the same point A. They both are in the same point A. One is person one, and another one is person two. The same situation. Person one is moving with velocity v. Person two is moving with velocity 2v. Person two is moving with velocity 2v. Now you understood it. Person one is moving double the person two. So person two is moving the double the speed of person one. Person. Okay, acha. All clear now. The situation is they are going in the same loop multiple times. Person two is moving, person one and person two going in the same loop for multiple times. They're just moving in the same loop. They're just moving in the same loop. But the speeds are now P1 is V, P2 is 2V. It is the double the speed of the person one. It is the double the speed of a person one. But they are moving in a same circuit. They are moving in the same circuit. They are moving in the same circuit. Maybe person one initially here, person two will be initially here. Next, person one will be initially here, person two will be initially here. So they are going. They are so going. Multiple times they looped. They are looping in the same cycle. They are going multiple times in the same cycle. So my question is, at any point t, at any point of time t, at any time t, do P1 meets P2. Do P1 meets P2. That means at any point, at any point, do P1 and P2 will come to the same point when they are looping with different speeds. Do P1 and P2 will come to the same point is my question. At any time t, maybe they have looped multiple times, but at a certain time t, do P1 and P2 will move? Do P1 and P2 will came to at the same point when they are in a different speeds and P2 speed is more than P1 and it is double. Maybe you can think it is more. Maybe it is three times. Maybe it is three times. Maybe it is two times. Maybe it is three times, two times. But that doesn't matter. But one of the speed should be greater than the other speed and they are moving in a circle. Do they meet in a same point? Is my question here. Do they meet in the same point? The answer is yes, they will meet at a same point. This is the concept. Yes, they will meet at the same point. How? How will be a linked list? How they are moving? You can also say like This is a circle. The point at P2. I'm telling like that point P2, P1, P1 is at point B, P2 is at point E. You can also think this is the starting point. Okay, don't worry about that. They looked. At certain point, this situation came. Okay, so what happens is P1 will move very slowly. Like P1 will move very slowly. You can imagine that for V velocity, sorry, in a circle, for velocity V, it will cover d distance. So let us suppose this is a distance d and this is a distance d. This is a distance d. Now what happens is I will another color. I will use another color. What happens is now P1 will move to C with velocity v d distance, right? Then where P2 will move. P2 will also move at the C point because they both are distance d. So P2 will also move to the same point C because P2 will move to 2D times. So P2 is moving 2 velocity means at in a single shot P2 will move 2D distance. It will cover 2D distance. If P1 is at moving with velocity v and it will cover some d distance. The same thing P2 moving with double the speed of P1, that means it will cover 2D distance. And the point where comes, it will they will meet when P2 is back. P2 is before than P1. P1 is before than P1. P1 is backside than P1. This point will definitely will come. This point will definitely will come. What I am saying is this is a loop. There is P1, there is P2, there is P2 here. So there is P2 here, P1 here. When they are looping, this situation will come. This is D, this distance is D, and this distance is D. Okay, now what will happen is P2, I'm again repeating, P2, sorry, okay, P2, if P1 moves, let's see your P1. Now the thing is what happens, P1 is moving with a velocity V, it will just move with a D distance, right? But each will, some people will move, like some people for 1 kilometer, 1 meter per second, some people will move some 1 meter, but some people moving with 2 meter per second can move 2 meters. That's what here. P1 moves to point this point with d distance. At the same time, P2 will move to cover 2D distance and will meet at the same point. That means the both points, the both persons are meeting at the same point. It is possible. It is possible. It is possible. You can see in algorithm point of view, you can definitely understand. I'm taking the linked list. You will see algorithm in a linked list point of view. You will understand much more clarity. But you understand in pictorial way, right? 6, 7, Now I'm considering the slow pointers. One is slow pointer, another one is fast pointer. Okay, I want to check whether if they meet at any point. The thing is, if they meet at any point, that means there is a loop. If there is a straight line, they cannot meet. They never meet. They never meet. But in a cycle, they will definitely meet. This is the main concept. This is the main core concept. In circle, they will definitely meet if they are going in a double the speed. That's the thing. Not double the speed. If one person is going the, if there are two persons, one is going with more velocity compared to another. That's the most important thing. Now, what I am going to do is, what I am going to do is, slow pointer will move one step forward, and fast pointer will move directly to it will directly jump to two steps. It will directly jump. It will directly skip the next node. It will directly go to next node. Like slow pointer will go to here, and fast pointer will skip this, and fast pointer will go to here. Right? Okay, let's see now. That now slow pointer will be here, and fast pointer will be here. Now again, fast pointer will go very fast. It will be here, and slow pointer will be here. Next, fast pointer will go to here. Fast pointer is here. Then fast pointer will go to here. Slow pointer will go to here. Next, fast pointer will go to here. Then slow pointer infinity. One, two, three. And slow pointer will come to here. And the situation fast pointer will go to here. Slow pointer will come to here. Next, fast pointer will came to here. Sorry, and slow pointer will go to here. Observe the situation here. Full pointer will, so it will loop so on. It will loop. It will directly loop. It will maybe loop. The slow and fast pointer will loop. Slow and fast pointer will loop multiple times. There will be a situation. Definitely will come. The situation will definitely come. The situation will be definitely come. What the situation will come is, let us suppose slow pointer is here. Okay, the first pointer is here. The situation is definitely will come. The situation is definitely will come. What will happen? Slow pointer will increase, will go to next node, and fast pointer will skip this and will go to here. That means they are meeting. They are meeting at a point at a node. They are meeting at a point at a node. This is the most important thing we should know. They are meeting at a certain point or certain node. So they are meeting at a certain point or certain. This is the meeting point. This is the meeting point. Whatever, if there is loop only they can meet. If there is no loop, they cannot meet. That means if they meet, there is a loop. If they not meet, there is no loop. You came to know this. So what will be the solution? I will do this in loop code instead of loop code. Loop, loop. Okay. Mm, acha. Okay. The same thing they're given. They are given a head of the linked list. You want to find whether you want to check whether the loop is there or not in the linked list. If there is a cycle in a linked list, this is the matter. If there is a cycle in a linked list, you want to return a true. If there is no cycle in the linked list, there is no loop. And they told that the next pointer is study this. There is a cycle in a linked list. If there is the same node in a list that can be reached again continuously by following the next pointer. I told right what is the loop. This is the definition of the loop. Okay, and and this is the loop, and we want to check whether the loop is there or not in a linked list. So first I am taking this node flow pointer is equal to head. Initially they are in a same point head point. So while condition slow is equal to slow dot next and fast is equal to fast dot next if slow is equal to fast return true. And what will be the condition here? See, if the condition here is if there is a loop, it will not go out of the loop. If there is a loop, it will go out of the loop when they meet at the same point. Then only they can go out of the loop. But if there is no loop, there will be strike length. Definitely fast will go to definitely fast may go to at last point, or fast may go to out of the it will go to none. It will go to out of the linked list. It will go to none. Same as the mid, finding the mid condition. When you are finding the mid, you have seen how the fast while finding the mid, we have seen like the conditions in the while loop, all the conditions in the while loop is there. If it is out of the loop or it is maybe at the last point. The same thing we are going to use here. Fast must not equal to null and then fast dot next must not equal to null. This is the condition you want to keep and run the code. Yes, maybe I need to run this code interface code. Okay, I got it there. Okay, I forgot to return the false. If it is coming out of the loop, we want to return the false. So yeah, thank you so much for seeing my video. Hope you understood this concept.